Hi, in this video we will see about statement and proof of Varignon's theorem of moments. Okay, so this Varignon's theorem of moments is important for the point of your examination. So many times this question has been repeated in the previous university examinations. Okay, now let us understand this Varignon's theorem of moments by a numerical example. Okay, so in one of the previous classes or one of the previous videos, I have solved this particular problem on coplanar concurrent system of forces. Here, a system of forces were given, and it was asked to find magnitude and direction of the resultant force, and we have done it. We got the magnitude of the resultant force as 433.7 Newton and angle as 51.47 degrees. Now what I will do is I'll consider a point A here. I'll consider a point A in the x-axis at a distance of 2 meter from the origin. Okay. Now what I will do, I will find sum of moments of system of forces about the point A. I will find algebraic sum of moments of system of forces about the point A. Okay. Now we will find moment of this 300 cos 40 force. 300 cos 40 force, how it is acting? Actually, it is acting here like this, and vertical component is like this, 300 sin 40. Okay. Therefore, 300 cos 40, 300 cos 40 into perpendicular distance of point A from the line of action. It is 0 because point A lies in the line of action of 300 cos 40 force into 0 plus 300 sin 40 into 300 sin 40 force. It is acting vertically upwards like this. So here we have the point A. So this is the line of action of 300 sin 40 force. So distance of point A from this line of action is 2 meter into 2 meter, and about point A this upward force is tending to cause clockwise rotation, sign is plus. Okay, and similarly if you find 400 moment of 400 cos 60 force, no, 400 cos 60 force, how it is acting? So this is the line of action of 400 cos 60 force, and this is the line of action of 400 sin 60 force. Again, moment of this 400 cos 60 force about point A becomes 0 because point A lies in the line of action, right? So only we will get moment of 400 sin 60 force. Therefore, moment of 400 sin 60 will be 400 sin 60 into perpendicular distance. Perpendicular distance is 2 meter, and about point A it is also causing clockwise moment, sign is plus. Then moment of 300 Newton about point A, it is also 0. 300 into 0 because point A lies in the line of action of 300 Newton force. Then moment of 200 Newton force, 200 into what is the perpendicular distance? 2 meter, and about point A 200 Newton is causing anti-clockwise moment, sign is minus. Here you put plus or minus, it will be 0. So let us calculate the answer for this. It is 300 cos 40 into 0, it becomes 0. So 300 sin 40 into 2. 300 into 2 means 600 sin 40, sin 40. Then 400 into 2 into sin 60 means 800 plus 800 sin 60, correct? Sin 60. Then 300 into 0, it becomes 0, minus 400, minus 400. So answer is 678.49, 678.49 Newton meter. What is this answer? This answer is the algebraic sum of moments of system of forces about point A. Now for this system of forces, we have determined the magnitude and direction of the resultant force. We got the magnitude as 433.7 Newton and direction as 51.47 degrees. Let me write the resultant force in the diagram. It is 433.7 Newton, 433.7 Newton at an angle of how much? 51.47 degree. At an angle of 51.47 degree. So for this, if I write the horizontal and vertical components, horizontal component will be 433.7 cos 51.47, and vertical component will be 433.7 51.47. 47, 433.7 sine, sorry, sine 51.47. Now what we will do is we will find moment of the resultant force alone about the same point A. We will find moment of resultant force alone about the same point A. And moment of this horizontal component of the resultant about point A becomes 0 because point A lies in the line of action of resultant force. Only we will get moment of this vertical component, that is 433.7 sine 51.47 into perpendicular distance is 2 meter, and it is causing clockwise movement. Sign is plus. So for this we will calculate the answer now. 433.7 sine 51.47 into 2 into 2. What is the answer? 678.55. 678.55 Newton meter. Now compare both the answers, that is sum of moments of system of forces and moment of resultant force alone. We can see that both the answers are same. Both answers are same with a very negligible deviation after the digit, after the point. Okay. So this is only the Varignon's theorem of moments, which states that the algebraic sum of moments of system of forces about a point. Okay, the algebraic sum of moments of system of forces about a point is equal to moment of resultant force about the same point. I repeat once again, the algebraic sum of moments of system of forces about a point is equal to moment of their resultant about the same point. This is what the Varignon's theorem of moments. Okay, this is what the Varignon's theorem of moments. So I'll write the statement now. Statement. Let me write the statement. The algebraic sum of moments of a system of forces about a point is equal to moment of their resultant about the same point. Okay, so I hope you have understood the statement of the Varignon's theorem of moments. Now we will prove this Varignon's theorem of moments. Next, proof. Okay, now to prove this Varignon's theorem of moments, let me consider two forces. Okay, let me consider two forces, force F1 and force F2. Let R be the their resultant. And let point O be the moment center. Moment center means it is a point about which the moment is measured. Okay, it is a point about which moment is measured. Okay, let me take this point as A. Now for the derivation purpose, let us consider OA. Join OA and consider it as y axis. Okay, and axis perpendicular to y axis is x axis, okay. Join OA, consider it as y axis, and x axis is the axis perpendicular to that y axis, okay. Now let d be the let d be the perpendicular distance of point O from the line of action of resultant force, perpendicular distance of the point O from the line of action of resultant force, and d1 be the perpendicular distance of the point O from the line of action of force F1, and similarly let d2 be the perpendicular distance of point O from the line of action of force F2, okay. Let me consider this point as point B, okay. Now as per the statement of Varignon's theorem of moments, we have to prove sum of moments of force F1 and F2 about point O is equal to moment of resultant force about the same point O, okay. So which means we have to prove that moment of force F1 is F1 into d1 plus moment of force F2 is F2 into d2 is equal to moment of the resultant force about the same point, that is R into D. Okay, we have to prove this equation now. Okay, we have to prove this equation. Moments of the sum of moments of system of forces about the point O is equal to moment of their resultant force about the same point. This is what we have to prove. This equation we have to prove. I will rewrite this equation as R into D is equal to F1 D1 plus F2 D2. Now what I will do, I will consider this LHS. In the LHS we have D, okay, we have D. Now we will formulate an equation for this D. For that I'll consider the right angle triangle OBA. Consider from right angle triangle OBA measure cos theta. Okay, let us take theta as angle of the resultant force. So here let me take theta as horizontal inclination of the resultant force, means angle of the resultant force with respect to x-axis, now whatever the angle theta here, we have the angle theta here, the same angle will be there here, theta, okay. So this angle means angle AOB is equal to the angle theta which is formed by resultant force with the x-axis. So you may get the question that how both the angles are equal. Let me give you a simple numerical example. Assume that this angle theta has 30 degree, okay, 30 degree. So if the angle theta here is 30, then what will be the angle here? So angle OBA is a right angle triangle, okay. Angle OBA is the right angle triangle. In that angle AOB is 30 degree, and at point B angle will be 90 degree, okay. Angle will be 90 degree. So the remaining angle here, how much it will be? It will be 60. Overall angle of the right angle triangle is 180. 180 minus 30 here minus 90 here will give 60. Okay. Now if you take angle OA and x-axis, it is also a right angled triangle. It is also a right angle. So 90 minus 60 here, what is the angle that you get? You will get 30 degree. Therefore by this we can say that angle theta is equal to angle AOB, that is theta. Okay, I hope this is clear for you. Okay, no problem. Now from the triangle right angle triangle OBA, you measure cos theta. Okay, you measure cos theta. Please ignore this writing. Cos theta is equal to, so here we have the angle theta, cos theta is equal to adjacent is D by hypotenuse is AO, D by AO. Okay, D by AO, therefore D is equal to AO cos theta. So we have got an equation for D. We have got an equation for D. D is equal to AO into cos theta. Therefore, I will take the LHS now, R into D. Therefore, R into D is equal to R into what is D? AO cos theta. AO cos theta. So, I will rewrite this equation as AO into R cos theta. AO into R cos theta. What is R cos theta? R cos theta is nothing but it is horizontal component of the resultant force. If we have the resultant force R and its horizontal component will be R cos theta, its vertical component will be R sin theta if angle is theta for the resultant force. Therefore, the R cos theta represents horizontal component of the resultant force. For that horizontal component of the resultant force, I will write it as Rx. Okay, means component of the resultant force along the x direction. I will rewrite it as, therefore, AO into Rx. AO into Rx. Rx nothing but horizontal component of the resultant force, or resultant component of the resultant force along the x-axis. So R into D is equal to AO into Rx. Okay, you call this as equation number 1. Call it as equation number 1. Now we have taken the LHS. Now similarly we will take the RHS. See, similar to R into D, okay, is equal to AO into R cos theta or AO into Rx. Okay, when you formulate the equation for R into D, you got the equation as AO into Rx. Similar to this R into D, if you formulate the equations for F1 D1 and F2 D2 by taking the corresponding right angles formed by the lengths D2 and D1, okay, lengths D2 and D1, you will get the equations for F1 D1 and F2 D2 as as similarly you can formulate the equation for F1 D1. You will get the F1 D1 equation as AO into F1x. What is F1x? Similar to the Rx, it is horizontal component of the force F1. Similarly, F2 D2 is equal to AO into F2x. AO into F2x. Okay. So no need to derive the equations once again. Similarly, you have to directly write the equations. Similar to the R into D is equal to AO into Rx. F1 D1 is equal to AO into F1x. F2 D2 is equal to AO into F2x. By taking corresponding right angle triangle formed by the lengths D2 and lengths D1. Okay. Now we can call this as equation number 2 and this as equation number 3. Okay. Now we will add equation 2 and 3. Taking equation 2 plus 3, it will be F1 D1 plus F2 D2 is equal to AO into F1x plus AO into F2x. So you can take AO common here, AO into F1x plus F2x. Okay, AO into F1x plus F2x. What is F1x plus F2x? F1x is horizontal component of the force F1, F2x is horizontal component of the force F2, which means it is sigma Fx. Okay, nothing but it is sigma Fx, and that sigma Fx is equal to horizontal component of the resultant force Rx. Okay, therefore you can directly replace this f1x plus f2x as rx. Okay, therefore f1 d1 plus f2 d2 is equal to AO into rx. Okay, so in the one of the means in the previous videos we have seen that the sigma fx can be either determined by using the resultant force, or it can be determined using the system of forces. Okay, using the resultant force we have rx, using the horizontal component of the system of forces we will get rx only. The same values we'll get the same values. Okay, if you add horizontal components of system of forces, you will have the same value. If you calculate horizontal component of the resultant force alone, you will have the same value. Okay, so this we have seen in the previous videos, or while solving the problems on coplanar concurrent system of forces, this we have seen it. Okay, therefore we can equate this f1x plus f2x as rx. Okay, horizontal component of the resultant force. Horizontal component, sum of horizontal component of system of forces is equal to horizontal component of the resultant force. Okay, you can call this as equation number 4. Okay, now compare equation 1 and equation 4. Okay, rd is equal to AO into rx, f1 d1 plus f2 d2 is equal to AO into rx. Therefore we can write r into d is equal to f1 d1 plus f2 d2. Hence Varignon's theorem of moments is proved. Okay, Varignon's theorem of moments is proved. Okay, so this completes the statement and proof of Varignon's theorem of moments. Still, if you have any doubt at any point of calculation here, or in any steps, if you have doubts, you can just comment on the comment section so that I can clarify your doubts. Thank you.